Okay, we want to find domain, intercepts, asymptotes, whether or not we hit the horizontal asymptote, and then use the information to sketch the graph. Okay, so first of all, factor if you can. This numerator does not factor because there's no addition subtraction, but the denominator is a difference of squares. Factors as x minus 3x plus 3. So from that, there's absolutely no canceling. My domain comes from setting the denominator not equal to 0. So from there I have two factors. X minus 3 cannot be 0 and x plus 3 cannot be 0. Gives me x cannot be 3 and x cannot be negative 3. All right, vertical asymptotes. Now in this situation, because there's no canceling, the vertical asymptote is very, very similar to the domain, but this time we set the denominator equal to 0. The exact same algebra gives us x equal 3, x equal negative 3. Horizontal asymptotes come from comparing the degree of the numerator and the denominator. So the degree of the numerator is an x cubed, so that degree is 3. And the degree of the denominator, look at the unfactored form, that's an x squared, so that degree is 2. And when the numerator has a larger degree than the denominator, there is no horizontal asymptote. Okay, intercepts. X and y intercepts we have left to find. Let me do the y-intercept first. So y-intercept, we plug in 0 for x, so we'll have 0 cubed over 0 squared minus 9, which is just 0 over negative 9, and that of course is 0. 0 in a numerator is fine, it's 0 in a denominator, that's a problem. X-intercept, we want y to equal 0, so we set the entire function equal to 0. First step is to multiply by the denominator, and that simplifies to just solving where the numerator equals 0. That gets us to 0 equal x cubed. To undo a cube, we take cube root. It's an odd root, of 0. It's an odd root, so I don't need a plus or minus. And of course the cube root of 0 is just 0. And that makes total sense, because I already found a y-intercept at 0, which is at the origin, so I should also have an x-intercept at the origin. Okay, last thing is to find whether or not the graph hits its horizontal asymptote. Well, we don't have a horizontal asymptote, so of course it can't hit it. Alright, now to tie it all together for a graph. Okay, so information that we have found, we have two vertical asymptotes at negative 3 and also 3. No horizontal asymptote. Y and x-intercept are both at the origin. Okay, now that's the only information that we specifically have. Let's also put this on a calculator to see what's going on. Always have to be careful about order of operations with a calculator. In particular, your entire denominator needs to be in parentheses. So I think it's better on the calculator to put it in the unfactored form. Alright, so here we have it. Let's look at this on the standard window, Zoom 6. Now I have two vertical asymptotes, so that's like dividing the graph into 3 different regions. Let's do the middle region first. We know we hit this point, and we have 2 vertical asymptotes to guide us. You can never, ever, ever hit your vertical asymptote. Should have arrows at the end. The calculator has drawn the vertical asymptotes like they are a part of the graph, but it's up to you to realize they should be dashed and to make sure that's the way they're on your graph. Okay, now, there was no horizontal asymptote. I can see pieces of my other 2 portions of the graph. I'm going to change my window just a little bit to see a little bit more. So I want to see a little bit higher and lower. So instead of going negative 10 to 10, let's go negative 20 to 20. Okay, and that just gives me a little bit more to see. Now, what I want to point out is although we're only finding the vertical and the horizontal asymptote, there is another asymptote sitting here. If I cover this up and just look at these two ends. It's almost like that's a straight line for those two ends. This is what would be known as a slant or oblique asymptote. And your text does talk about them, but we're not requiring you to find them. I just want to point that out so that you can see that when you draw this type, you can kind of visualize, aha, there is an asymptote there, I just didn't have to find it. Okay, so let me go back to the standard window again. Slant asymptotes occur when you don't have a horizontal asymptote. So if I kind of keep that in mind, here I have a vertical asymptote that I cannot hit. I've got to make sure to follow the vertical line test, so do not loop that back around on itself. And then I have this piece over here, which also has a vertical asymptote and then comes off with this slant. And I've got kind of a line that would go through there. Okay, so there is my graph for this rational function.